In the previous videos, we looked at the derivative of x to the n, and I focused on polynomials. What I want to do now is take this derivative rule that the derivative of x to the n is nx to the n minus 1, and show you how it works for sort of general power functions. In particular, there's functions like the square root function, right? F of x equals the square root of x. I can think of that as x to a power, where the power is a half. And then I can use this derivative rule, although I haven't proven that it really works yet, but you'll see that it does. The derivative of x to the half power would be, it's just to bring the exponent out in front, and then drop it by 1, so I've got 1 half minus 1. That would be 1 half, let's see if I can write this, 1 half x to the negative a half. Sometimes I'll write that as 1 over 2 times the square root of x. Right? Now I'm pretty sure that we did the square root function in a previous video using the definition, and I'm pretty sure that's the answer we got for the derivative. So the power rule works here. Right? Another example, if you've got the cubed root of x, right? That would be x to the 1/3 power. So the derivative is 1/3 x to the, subtract 1 from the exponent, 1/3 minus 1. So this would be 1/3 x to the negative 2/3. Okay. Other functions that you might not immediately think of, but are power functions, are x to negative exponents. So something like f of x equals 1 over x. Think of that as x to the negative 1 power. So f prime of x is, according to the power rule, the exponent comes out in front, and then you subtract 1 from the exponent. So I've got negative x to the negative 2, which would be negative 1 over x squared. Right? So this works for anything, any positive, negative, whatever. I mean, even if you got both of them going on here, how about f of x equals 1 over the square root of x? How do you take that derivative? Well, if I think of this as x to the negative a half power, see if I can write that. There we go. Then the derivative, right? This is f prime, is minus 1 half x to the minus a half minus 1, which would be minus a half x to the negative 3 halves. Okay. Put the exponent out in front and subtract 1 from the exponent. That's the power rule, and it applies to all sorts of functions. As I've said, we haven't proven that this works yet, but when we get the notion of the quotient rule, I'll be able to do these negative exponents. When we get the notion of implicit differentiation, I'll be able to do these radical exponents, and then the chain rule will be able to do the irrational exponents as well. But anyway, there's some more examples for you.